A manufacturer of a precision tool checks the lengths of each tool randomly in selected batches of 12 tools. 120 batches of 12 tools are checked, and X, the number of tools in each batch which is too short, is recorded. The summary statistics are that N is 120, sigma X is 220, and sigma X squared is 642. A, calculate the number of the tool in a batch which are too short. Calculate the mean number of tools in a batch which are too short, and the variance of the number of tools in the batch which are too short. We'll deal with the rest of the question later. So these are the summary statistics. So X bar is the sum of X over N. So that's going to be 220 over 120, which is 11 over 6, or 1.83 recurring. The variance is calculated by sigma X squared minus N times the mean squared divided by N minus 1. So again, we can get the numbers from the summary statistics, which is 642 minus 120 times 11 over 6 squared over 120 minus 1. Use the fraction button on your calculator, and that will give you 716 over 357, or 2.01, correct to 2 decimal places. George decides to use a binomial distribution to model the number of precision tools which are too short in a batch of 12. Write down the parameters that George should use in his model. So if we let X be the random variable, the number of precision tools which are too short in a batch of 12, then X will be binomially distributed with NP. N is quite easy because that's going to be 12. We've got to calculate P. But the mean for a binomial distribution, E of X, is N times P. We've already calculated the mean, which is 11 out of 6, which is equal to 12P. And therefore P will be 11 over 6 times 12, which is 72. So our parameters will be X is binomially distributive with N being 12 and the probabilities of success being 11 over 72. Use George's model to determine the expected number of batches out of 120 in which there are less than 3 tools which are too short. All right, taking the model, first of all, we need to calculate the probability of X being less than 3, which is the probability of X being less than or equal to 2. So either on your graphics calculator, and here I just use GeoGebra, you can calculate the value that's required for the distribution, and we're going to get 0.7262. And then the estimated number of tools which are too short in a batch out of 120 will be 120 times 0.7262, which is 87.1, which is rather a lot. Okay, this has been a video to show you how to set up a binomial model. In the notes of this video, I've put a link to my video page website where you can get the link to thousands of videos. And thank you very much for watching. Maybe you could subscribe to my channel.